An absolute requirement for the special theory of relativity is the speed of light is constant for all observers and is independent of the velocity of the emitting source. If that is not the case, Einstein's theory would crumble. When a rocket emits a flash of light, the light propagates in all directions at a velocity of 300 million meters per second. In 33 billionths of a second, the light will reach a distance of 100 meters in all directions. The center of that light sphere will reside at the point where the light was emitted. Each astronaut is precisely 100 meters from the source of the light. Since the velocity of light is constant for all observers, they each saw the light at the same time. What if the rocket and the 4 astronauts were moving relative to Carl, the observer? The rocket will emit a pulse of light as it passes Carl. Remember, the speed of light must be constant for all observers. The light sphere that results will therefore expand in all directions at the same rate with respect to Carl. How could this be? In the rocket's inertial reference frame, all the astronauts saw the light at the same time. In Carl's reference frame, the astronauts are seeing the light at different times. In order to satisfy all observers, one of 3 things must have happened. 1. The rocket and Carl exist in parallel universes. 2. The rocket emitted 2 pulses of light simultaneously. The center of one is at rest with respect to the rocket and the other with Carl. Or 3. The velocity of light is dependent on the velocity of the emitting source. If the velocity of light is dependent on the velocity of the emitting source, Carl would see light moving to the left at 1.5 c and to the right at 0.5 c. The special theory of relativity requires the universe to behave in bizarre ways. Our obsession with the constant speed of light has stifled the progress of science for over 100 years. If we accepted the fact that the velocity of light is dependent on the velocity of the emitting source, objects would not have to compress, time slow, or mass increase merely because something is moving relative to them.